Section 1.1, Basic Set Concepts, Video 1. In this video, we will cover the following objectives. Define a set and write a set using roster method, word description, and set builder notation. In everyday life, objects with common characteristics are often grouped together to represent one entity. We do this without realizing it. And in math, that is known as forming a set. So here we are going to talk about how to group objects into sets and how to represent sets using mathematical notation. Let's start with some definitions. A set is a collection of objects whose contents can be clearly determined. The individual objects are called elements of the set. A set must be well defined, meaning that its contents must be clearly determined. Example 1. Determine if the following sets are well defined. Part A. The collection of all NHL players who scored a goal in a playoff game. This set is well defined because we could look at the records and formulate a list of all National Hockey League players who scored a goal in a playoff game. We can clearly identify the contents of that collection, so therefore that is a well-defined set. Part B, the collection of all odd numbers that are multiples of 3. That is also well-defined because we can clearly identify the numbers that are odd and that are also multiples of 3. Part C, the collection of the prettiest places to live in the U.S. That is not well-defined because that is a matter of opinion. The set of places on my list might not be the same as the set of places on your list, and so the contents of that collection cannot be clearly determined. Now we'll move on and talk about how to use mathematical notation to represent sets. So first off, sets are often named or identified using capital letters. And there are 3 common ways to denote a set. Roster method, word description, and set builder notation. In roster method, elements are placed in braces and are separated by commas. So for example, we could say F is the set containing the elements red, white, and blue. And that is denoted with these braces, the elements red, white, and blue listed with commas separating them. The next common way to denote a set is using a word description, which is basically what it sounds. Words are used to describe a set. So for example, we could say that F is the set containing the colors of the American flag. And so we would know that that set contains the colors red, white, and blue. Lastly, we have set builder notation. This is a mathematical notation that is used to describe a set, and it contains 3 parts: a variable, a vertical bar or colon separator, which is read as such that, and also a statement indicating the properties of the set. So for example, we can say that F is the set of all X, that's the variable, representing the general element, and then that vertical bar is read such that, and then we have a statement indicating the properties of the set. In this case, X is a color of the American flag. And notice that that is placed in braces. So again, that would be read, F is the set of all X such that X is a color of the American flag. Let's practice going from a word description to roster method and then to set builder notation. Example 2. Write the following sets using roster method and set builder notation. Part A. The set of the seasons of a year in the U.S. So we're going to name this using a capital letter. I will use capital letter S. You may use whatever letter you would like. Now with roster method, we're using braces and we're basically just listing the elements. So we have spring, I'm listing the seasons in the United States, summer, fall, and winter. So we're listing the seasons, putting them in braces, and separating them by commas. Notice that order does not matter, so we could write those seasons in a different order and it would still represent the same set. All right, so that's roster method. Now let's go ahead and let's talk about set builder notation. So I'm going to again use capital S. So S is the set of all. Now I need a variable. I'll use X. We can use whatever variable we would like though. The set of all X, and then a vertical bar or a colon means such that. So we could use whichever one. I'll use a vertical bar. Such that, and then now we need a statement identifying the characteristics of the set. So it would be X is a season of a year in the U.S. Notice that those are also placed in braces. So again, that is read. S is the set of all X such that X is a season of a year in the U.S. Okay, part B, we're going to look at the set of months of a year that begin with the letter J. I'm going to use capital M. We could use whatever letter we would like. With roster method, we're just listing the elements. So we have January, June, and July. And again, those elements can be listed in any order and it would still represent the same set. So that's called roster method. Okay. Set builder notation would look like this. So we have M is the set of all, let's use a different variable just to mix it up. How about the set of all Y such that Y is a month beginning with the letter J. So notice how we're using a variable, and that variable is listed twice. So we're listing that variable in the general sense, and then the variable is listed again in the statement giving the characteristics of the set. Okay, lastly, we're going to talk about elements. So again, elements are the items that make up a set. This symbol here, it kind of looks like an E, a fancy E. That denotes that an element is a member of a set. If we have that symbol with a line through it, then that denotes that an element is not a member of a set. Example 3. Determine if the following are true or false. Part A. Benjamin Franklin is an element of the set of all X such that X is a president of the United States. So this is basically the set of all U.S. presidents. And in this statement, we are saying that Benjamin Franklin is an element of that set. Well, that's false. Benjamin Franklin was never a U.S. president. Part B, 113 is not an element of the set containing 246 ... 658. So with those three dots, that's called an ellipsis. That's basically saying that we would continue the pattern until we get to the final element. So this set consists of 2, 4, 6, 8, 10, 12, 14, 16, etc., all the way to 658. So in other words, this set contains the even numbers starting with 2 and ending with 658. And in this statement, we are saying that 113 is not an element of that set, which is true. 113 is an odd number, and it's not an element of that set of even values. Part C, 333 is an element of the set of all Z such that Z is odd and is a multiple of 3. So basically, we are dealing with the set of all odd multiples of 3. 333 is an element of that set because it is odd and a multiple of 3. This concludes example 3.